Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope everyone is doing all right out there. I don't know what the title for this lesson is going to be. It depends on what class you're in. That doesn't matter. But what does matter are our three goals. Let me figure out how to raise three fingers. Our three goals are what matters. Our first goal is going to be introduction to the undefined terms in geometry. Our second goal is going to be creation of defined terms from undefined terms. And our third goal is how to properly name defined and undefined terms. So, in our first goal, we start off with undefined. In our previous lesson, we discussed undefined. And I hope that we have a little bit better understanding of what undefined means. And I'll explain why these are undefined as we work through them. But remember, undefined means that there's no agreement on the meaning. So we saw a previous lesson where hopefully we understand why people had a disagreement about what dividing by zero meant. And in geometry, we start with three undefined terms. These are the basic ingredients we build geometry from. So in that lesson that I talked about undefined terms, you saw that I was able to create a new idea when I defined that term. And so these three ideas that we're going to talk about today, these are the basic ingredients for what we're going to learn for the next couple months in this class. And so I guess let's just jump right into the three undefined terms. A point. A point represents a specific location and is represented by a dot. And it has no dimension. This statement right here, having no dimension, that's what makes it undefined. That means that it has no size. Okay, and so if we have no size, how do you represent a specific location? And that's where the disagreement comes in and what makes a point undefined. Our second undefined term, that's a building block for geometry, is a line. It's straight, it has no thickness, and it extends forever in both directions. This is an example of a line, and it's one-dimensional. So the problem people have with lines, what they get in an argument about, is it has no thickness, right? And since it has no thickness, how does it have a location? And so this is the disagreement people have. There's actually arguments about this. And this is what makes a line undefined. Our third undefined term, that's a building block of geometry, is a plane. Not an airplane, but what we call a plane. And a plane is a flat object with no thickness, and it extends forever in all directions. This picture is actually a plane. As we get into the later goals for this lesson, you'll see how to recognize a plane versus what we call a parallelogram, which you'll see later on. But this is flat, it has no thickness, and extends in all directions forever. And the fact that it has no thickness, that's where the argument is made. Like how does that work exactly? I don't know the sides of the argument, but I know that's what they argue about. A plane is what we call two-dimensional. So I'm going to go ahead and erase the board, set up the second goal, and I'll be back. I'm back. Here we are, and we're gonna start our second goal. Let me learn how to talk. I think I can do this. All right, so remember our second goal is we're going to create defined terms from undefined terms. And these are defined because everybody agrees what these are. Okay, even though they come from things that people argue about, we all agree what these objects are. So defined terms right now are made from undefined terms, and for now they are made from lines. So what we're going to do is we're going to start with a line. And we're going to add 2 points to the line, like so. Draw 2 points on a line. Since a line has no size and points have no dimensions, we can put them on there, no big deal. All right, so now I have a line that has 2 points. From this, I'm going to be able to create 3 different objects, okay? By erasing the line on either side of a point, we create 2 different rays. So if I erase the line on this side, I've created a ray. And the ray is going in that direction. Now if I erase this side, I've created a different ray, which goes in this direction. Even though both of them share these in common, they are considered different. Okay, so that's how we create an array. We just erase part of the line. We call this right here, this is now what we would consider an endpoint. And this is also an endpoint. Okay. Now, we get array if we eliminate part of the line on one side of the point. If we erase the line on both sides, we create what we call a segment. So if I erase the line right here and I erase the line right here, I have what we call a segment. Now a segment has two endpoints. So there's an endpoint and there's an endpoint. So this has two endpoints. And we all agree that these are defined. We all agree what these are. Rays have an endpoint and then they go in one direction forever. They have an endpoint and they go in one direction forever. Segments have two endpoints. Okay? I'm going to erase this and I'm going to create one more defined term from a line. So I'll be back. Let me erase this and I'll be back. I'm back again. So let's finish our second goal here. And what we're going to do is we're going to create an angle. And an angle is created when two rays share an endpoint. So we'll walk through the steps to create an angle. So again, these come from lines. So what we're going to do is we're going to start with two lines that intersect. So just draw any two lines that intersect. And we're going to put a point at the intersection. So this is where they cross. They cross right here. Okay. We're going to add one more point to each line and erase the other side of the intersection. Now we have an angle. So here's where they intersect. I'm going to add a point, one more point to this line. I'm going to add one more point to this line. And I'm going to erase the other side of the intersection. And now I have an angle. And so hopefully you understand how defined terms are created from undefined terms. Now, I put the point here. I could have put the point here and then erased this part. Or I could have put this point here and erased this part. So we could have actually created a couple different angles, right? So this isn't the only angle that could be created from this situation. Let me draw the rest of this picture just to reinforce that concept here. So I'm not going to put the point here. I'm going to put the point here. And I'm going to erase the other side of the intersection. And now I've created a different angle. Right? So again, angles are created when two rays share an endpoint. I have a ray that starts here and goes in this direction. I have another ray that shares this endpoint and goes in that direction, and I've created an angle. So we're going to go ahead and start our third goal, which is how to properly name defined and undefined terms. We have a point. We're going to learn how to name a line, a plane, a ray, and a segment. So let me erase this, and I'll be back for the last time on this lesson, I promise. I'm back for the last time, I promise. Let's go ahead and work on our third goal, how to properly name defined and undefined terms. So we see all the players that we've been introduced to so far, and we're going to learn how to name all of these. So we'll start off with a point. So here I have an example of a point, which is a dot, and it has a capital letter next to it. And we would name it, we could just call it A, or we can call it point A. And that's how we name a point. Pretty simple. The next object we have, an undefined term, which is a line. There's more ways to name this, okay? So notice I have 2 points that are named as B and C. I also have a cursive letter L. So we can call this line L, or I can call this line BC. I can also call this line CB. Let me put an or right there. But I can also use symbols. I can write the letters BC, and above it, I can put a little line with arrows. That was not drawn very well. These arrows tell me that I go through C and through B and I continue. I could also name this like this. We're going to be using this form most of the time. Again, pay attention. Are there arrowheads above it? Which means that I go through the point and continue. Okay, so that's how we name a line. Here I have array. Array, you have to be very specific. I'm gonna name this ray ED. Now I cannot call this ray DE. I have to call it ray ED because this is where we start. Okay. Now I can also use a symbol like this. I can call this, I can write the letters E and D. I'm not going to put an arrow over E, but I'm going to put an arrow over D. And what this tells me is I start at E and I go through D and I continue without N. If you see something that looks like this, actually you can also write it like this. That's saying the same thing. I start at E and I go through D, and I know that because the arrowhead is over the D. Now, if I write something that looks like this, what that tells me is I start at D and I go through E. So this would be the ray that I just named. There's D, there's E. So it's very important that we have the arrowhead over the correct letter that we are going through and past. Okay, so that's how we name a ray. A segment. Again, like before, we can name this many different ways. I can call this segment FG or segment GF. Notice that F and G are where it ends. Okay. Now I can also make it symbolic using other symbols, like I did with lines and rays. Notice I stopped at E. I'm stopping at both endpoints. So if I wanted to write this using math notation, it would be a segment, no arrows, with an FG or a GF, where those are my endpoints. That's how I show you that I'm talking about a segment. All right. A plane. Oh man, this plane has a lot of different names. The easiest name is to use a cursive letter. We could just call this plane M. Or we can use the points that are on the plane. Now these points can't make a straight line, and I'll get into that later, but they have to, make a triangle of some sorts. So we could name this plane HIJ. Or we could call this plane IJH. Or, hopefully you get the point. But I can't use M because M is not associated with a point. So I have to either name it plane M or I have to use 3 letters. Alright, the last object, an angle. There's 3 ways that I can name this angle. But before I go any further, let's name this point that the rays share. This is called the vertex of an angle. It's like the elbow. A vertex is like the elbow of an angle. All right, so we can call this, this has a lot of names. We can call this angle KLM. Notice the vertex is in the middle. I could also call this angle MLK. Again, my middle point is a vertex. I can also call this angle L because L is the vertex. So I can name this only using the vertex. And as I write this lesson, I wish I would have had a different vertex letter, but that's okay. I will make a very big distinction between the symbol. So this is how we write it using a word, but we can also write it symbolically. I can say angle KLM, or I can say angle MLK, and finally I could also call this angle L. So this would be the way that we properly name these objects. And again, we're going to use the symbolic notation here. You know, we'll probably just say A, and here it's going to be either one of these. Here we're going to use this and this. Here, we're going to have to spell out plane. There's no symbol for plane. And we're going to use this for an angle. So hopefully this explains how to name these shapes, and hopefully you understand where they come from. So I'm going to go ahead and end the lesson here. Again, I hope everybody is doing all right out there. Have a good day, everybody. Bye-bye.